Welcome back my dear friends and participants for this multi-criteria decision making course under NPTEL MOOC series. And as you know, this course is spread over 12 weeks with 60 lectures, and each week we have 5 lectures, each lecture being for half an hour, and after each week we have one set of assignments of 10 questions, and after that total course is over, we will have a final examination. Once again a very good morning, good afternoon, good evening to all the set of people who are watching these lectures. My good name is Raghunandan Sengupta from the IME department at IIT Kanpur. And if you remember, in the last few weeks we have been going through the non-parametric methods, and we had covered a lot, and as the methodologies of trying to solve the problem were almost similar. So, I just highlighted the main context, main idea, and the different methodologies we have considered was the Electra method, epsilon Electra, Topses, Vicor, and the last part we discussed the AHP. So, AHP is basically the analytical hierarchy process. One other method we will discuss in the first lecture of the 12th week, which is the 56th lecture, is the idea of data envelopment analysis, and this is very heavily used in economics, in econometrics, in production economics, where you want to basically rank different decision making units or organizations. Now, all the other methods of Electra, epsilon Electra, Topses, Vicor, AHP we have discussed is basically the it was leave aside AHP. The other 4 methods we discussed was basically the closeness to the best solution, furthest it is from the worst solution. We use the concept of concordance matrix, discordance matrix, in some case we use the indifference concept in epsilon Electra. We have used the concept of AI, PIS, NIS, and then we found out the ranking method for all the alternatives based on the criteria. First, we compared them taking one at a time and then collectively. In HP, it was a little bit different, where obviously the comparison was between alternatives based on the criteria. So, for the example where we considered 2 students, Ram and Shyam, were selected for the MBA programs, and they had different set of criteria to select the institute, or else consider the example where you are buying a car. So, in all these methods including AHP, there was a combination of quantitative as well as qualitative different criteria in order to judge how you will rank. DA is also in the similar line, but it is more from the point of view of operation research, and I will come to that later on, because operation research and the simple concept of linear programming and all these things is considered to be a part and parcel as a prerequisite for this course. So, I will just give you the highlighting points of these methodologies, and then you can solve the problem accordingly. I will only concentrate on the formulation, other things are very straightforward. So, this is the 56th lecture out of the 60 set of lectures. The idea is multi-criteria decision making. We have already covered multi-objective decision making, multi-attribute utility theory. Now, we are considering multi-attribute decision making. Even though the methodology of DEA you may find out some mathematical formulation, but still I am considering it as a part of non-parametric methods, and why I will just highlight few of the points as we proceed. So, the coverage is data envelopment analysis, and we will consider it accordingly. Now, where is data envelopment analysis used? So, for the examples we considered, if you remember, I was always trying to harp on 3 examples, trying to buy a car where there can be different criteria, some which are quantitative, some which are qualitative, some are objective, some are subjective, trying to buy an apartment in a particular city with different sets of criteria, some may be price, some may be locality, some may be closeness to the school or how safe it is. Another case was trying to choose the institute where you want to go and study. In the similar line you can use DA, but DA considered that I want to analyze and rank, or I want to find out the ranking methodologies or ranking of different type of alternatives. Here the alternatives are not mentioned or named as alternatives. In DA method they are known as the decision making units or DMU as written in the slide. So, what are the decision making units? Consider that the same example, we want to choose the best college, best university. So, when you make a list of the different type of universities, be it engineering college list from where you want to take, or the management school or social sciences, you have different sets of priorities set. Somebody wants to basically go to the best college where the quality of teaching is excellent, somebody wants to look at the job opportunity, somebody wants to have a look at what are the internship opportunities, and so on and so forth. Or else consider a totally a different example, that you want to basically analyze how are the different type of companies under the same sector are doing. Consider the car industry. So, there are many different car industries companies in India. It can be Hyundai, it can be Honda, it can be Volkswagen, it can be Tata, it can be Mahindra. So, you want to basically analyze how does this set of companies compare amongst themselves, considering there are different sets of inputs and there are sets of outputs. Now, the word of sets of inputs and outputs you are hearing for the first time in context of DA, and obviously, we have not encountered these two words in other non-parametric methods. So, we consider a DMU in a very simple sense is a black box or a unit where different inputs are utilized in different quantums, in different units, and the units of input can be electricity, can be manpower, can be water, can be raw materials, anything, and outputs can be different type of outputs considering the case of car. So, it can be what type of car the companies are making, is it a passenger car of certain cc, or is it a heavy vehicle or a SUV, and so on and so forth. Now, if I consider the case of the choosing the educational institute, consider for our example, education institutes are all the IITs. So, in the IITs obviously, the input would be the students, input would be the infrastructure, input would be the faculty members, input would maybe the location, and what would be the output? Output can be the type of jobs which the students get, type of research output on the front of paper, books, different type of projects which are sold in the market. So, based on the set of inputs and set of outputs, you want to basically rank these decision making units. So, basically this is the background based on which we are going to study the DEA method. So, let me continue the discussion further on by reading the slides. Consider you have a system or so called decision making unit or units, which takes some inputs in different quantum, in different units, process them and produces some outputs. Now, when I am using the word processing, processing can be different. It can be a chemical process, it can be a mechanical process for an organization which is producing some goods, and for the educational institute, you are basically processing the students to be well acquainted with the job market, well acquainted to for the academic world. Now, in another important point is, if you remember, I did mention, and I did mention it few times, when we are solving the problem, that if you remember the concept of discordance set or matrix, if you remember the concept of how far it is from the most positive point, how far it is or how close it is from the most negative point. So, those theoretical points. So, we are considering the negative value for taking a decision, for choosing an alternative. So, in this case when you are considering a DMU, the question may crop up is that can we have some outputs which are negative in nature? Yes, we can have. Say for example, when producing some steel, making some steel or making some cards, the pollution can be considered as an output which has negative impact. So, in the same way as we are analyzed, you can consider the negative discordance concept or the how close it is to the negative theoretical point. We can also analyze the concept of negative outputs considering the DEA methodology. Examples of systems or DMUs can be a machine, a factory, an hospital, an airport and a university. One example of the university I have just mentioned, and factories for the example consider that I am considering all the different type of small car manufacturing companies which I mentioned, Tatas, Mahindras, Hyundai, Honda, then Volkswagen and all this list. Invariably, there may be many such similar systems of DMUs which are taking these inputs in some combinations or sets of inputs in some combinations or in different quantums, processes them and produces the outputs also in different quantums. Example, consider two different the old IITs which was built in India just after independence and consider the new IITs. Maybe the amount of land the old IITs have with respect to the new IITs may be different, maybe the total infrastructure may be different. So, we will consider the outputs and inputs, here its inputs and outputs would also change accordingly. So, it is basically what the situation is. Another point is that when you are considering the factory example, it may be possible a certain cc of car is not being manufactured by Tata Motors. So, in that case the output for that company or for that DMU which is Tata Motors will be considered nil, but still we will try to basically fathom it how it can be considered in trying to model the DA optimization model. I am using the word optimization for the first time, and as I did mention, it is a different version of optimization and you will see it is a very simple in nature. In such cases, we are required to find out what is the rate of processing of these inputs or outputs or what is the efficiency of the system, so that we can compare them amongst themselves and also find out to what degree they are deficient when compared to so called ideal system or a full efficient system or an efficient DMU. Maybe we are comparing two companies and the first company is operating at 100% efficiency. So, and obviously, you will try to find out that what is the efficiency of company 2 and how it can be improved. Now, here is one important point to mention and we will revisit that later on. Consider, I will give you two examples. Consider that you as a teacher, you are trying to basically give scores for one examination which you have conducted, and the grading system can be based on two factors, one is relative grading, one is absolute grading. In the case of relative grading and absolute grading, what you do is that in the absolute grading you consider the maximum marks as it is and then basically give the grades or the marks of the other system exactly as the student he or she would get. In the relative concept, the marking of the highest student is normalized to the maximum scale and corresponding to that scaling system the other students marks are also analyzed. Now, the question is that why did I mention this example? Consider you are trying to compare all the steel industries or steel companies in India. So, consider the companies Steel Authority of India, SAIL, it can be other private companies which are JSW Steel and so on and so forth, which are operating in India. And when you compare them, it may come out, say for example, that out of the 10 different steel companies which you are considering, JSW Steel and Steel Authority of India have an efficiency of 1, and correspondingly Tata Steel has an efficiency of, say for example, 0.95. Now, the question is, does that mean that the first two companies which I mentioned, JSW Steel and SAIL, Steel Authority of India, are operating at their highest level of efficiency? The answer may not be emphatic yes, it may not be possible. Why? Because you are comparing the companies of the sample set which is in India. So, if I basically increase the sample set of trying to compare, like say for example, bring other companies into the picture, Nippon Steel, POSCO and other companies in Germany, it may be possible SAIL and JSW Steel, then their efficiency may be less than 1. That means, when the comparison basically is much more based on the population, then actually we will be able to get the overall efficiency of those set of companies. So, this would also be remembered as we proceed with this DEA formulation. Now, what are the nomenclature? So, I will basically mention the nomenclature. They have similar set of analysis or the ideas which I have already mentioned. So, here M is the number of inputs. If you remember, there M was number of alternatives, N is the number of outputs, there N was the number of criteria. Here the number of alternatives, which is the DMUs, we are considering as K, and I will mark with a different color, K as in blue. So, we want to find out based on the set of inputs M in number for each DMU, outputs being N in number for each DMU, we are going to find out the efficiency of the K number of DMUs. And what are the variables? Variables are, if you read it, is xik is the ith input variable for the kth DMU, yjk is the jth output variable for the kth DMU, uik is the input weight for the ith input weight for the kth DMU, and finally vjk is the jth output weight for the kth DMU. And what is ijk? Let me verify once again. Small I changes from 1 to m, which I am highlighting with blue color here. Small j changes from j is equal to 1 to n, which I am highlighting in green here till capital N. And finally, the value of k, which is for the DMU, changes from k is equal to 1 to capital K. So, you have basically I j k, I changes from 1 to m, j changes from 1 to n, and k changes from 1 to capital K. Now, before we consider the simple model, we are going to consider the very simple model. There can be 3 different types of productions and returns concept. Now, this basically comes from the concept of how the economy is doing. So, we will consider that is in an increasing return to scale market or economy, one is a decreasing return to scale and one is a constant return to scale market. Increasing return to scale means the more you produce, more the profit is, more the output is, more the revenues are. So, per unit increase would basically mean your total profit function is on an upward trend. Decreasing return to scale means more you produce, the overall output, if it increases, it gives a negative return, in the sense it is decreasing, revenues are decreasing, and constant means the more you produce, the rate of change of the revenue remains constant. Now, these 3 graphs of increasing, decreasing and constant we have already seen, but not in this context, we have already seen in the concept of the risk. If you consider the concept of risk, there was marginal utility was increasing at an increasing rate, were increasing at a decreasing rate, and was increasing as a constant rate. So, the graph which we had in the context of risk was very simply given like this. If you have the wealth W along the x axis, utility I am only utilizing the symbol U, which is along the y axis, the graphs would be, the blue one would be where the rate of increase is constant, the green one would be where the rate of increase is increasing at increasing rate, and finally, the red one would mean that is increasing at a decreasing rate, because the slopes are changing. If the blue one constant slope dy dx or du dw, and the green one is increasing, rate is increasing, and the red one it is decreasing, that is du dw is decreasing. Now, let us consider the diagram in more details, and if you consider the decreasing return to scale diagram in details, other things would come out very easily. Consider I am plotting the bundle of inputs, all the inputs which are there along the x axis, which I am just marking for, I will erase the color, but I am marking for simplicity for all the viewers and the readers to see. This I p which is input, I am marking along the x axis. The output I am again marking in red is along the y axis, and the graph which is here, which I will highlight using the violet color, which I will again erase, is this one, is increasing, but the slope is slowly falling, and this is what I want to now highlight. Now, notice here there are DMUs are on this side of the curve, depending on all the DMUs to be maximum efficient, they should lie on the curve of the production possibility frontier, because it is decreasing return to scale. So, if a DMU is with suffix 1 and considered is inefficient, because it is not on the efficient frontier line. So, it can reach the efficient frontier line in many ways. It can go either vertically up, which is the blue line, it can go horizontally to the left, which is the pink one, and apart from the infinite ways it can go, I will only consider one, and why I will do that I will come to that later, is the one which is shown in green, which is moving radially in the direction till it touches the curve. Now, what I mean by radially is basically, if I consider the green line, the angle which is there, which I am drawing here is 90 degrees, because that would be considered as the shortest possible way in trying to reach the point of the curve, such that the DMU 1, which was inefficient, can be made efficient. Now, when I say the word efficient and I have marked the blue, green and the pink one, what does that mean? Now, that means the following. If I consider the pink one, and if you notice the slide, the pink one means the input was at IP12, which I am now highlighting here. The output remains same, which is OP11, and the input decreases from IP12 till IP, see for example here. That means, at the same level of output, the inputs are being decreased. That means, I want to maintain the same output, but my total input is being decreased. Example, I may hire less number of people, all the contractual laborers. I am just going to the other example of, say for example, the steel companies which I mentioned or the car companies which I mentioned. I want to produce the same amount of output, but the more I produce, the revenues would decrease would start decreasing at a increasing rate, and I want to basically maintain my output, but use less input. Less input may be one example, can be I recruit less number of people, do not hire the temporary workers, give some extra overtime to the permanent workers and do that work. Another way can be I want to basically maintain my input and increase the output till it reaches the vertical height, which is basically DMU1 efficient, which is blue in color. This DMU1 efficient input based is the horizontal movement onto the left hand side, if you are seeing the slides yourself. And in the case when I am considering the blue one, which I just mentioned, inputs are being fixed, outputs are being increased. And in the case of the DMU efficient, which is the green one, where it moves radially, there what we are doing is we are trying to, based on DMU 1 which was inefficient, we are trying to decrease the input as well as increase the output. That means, doing a balancing act on based on that. Now, which means that the DMU 1 which was inefficient can reach the efficient frontier in different ways, and these three are the three different scenarios based on which DMU 1 which was inefficient can reach. Now, if you have noticed one thing in the graph, the blue one is marked as DMU 1 efficient, and then in the bracket in the suffix I have written OP, which is output oriented, because their input is not being changed, output is being increased, because it is vertically up. In the case when I am going horizontally onto the left, it is written in the pink one DMU 1 efficient, and in the suffix is written I/P, which is input oriented, which means that output is being kept fixed and input is being changed. So, this input oriented model and output oriented model are the ideas of an input oriented formulation of the problem, and output oriented formulation of the problem will be coming up within few minutes. Now, similarly, if I consider the decreasing return to scale, I have spent quite a lot of time in trying to explain the decreasing return to scale, but there is one small change in the graph. If you consider the graph here, which we considered, there the output were all considered along the y axis and the inputs were all considered along the x axis. So, in this graph they are just interchanged, that means output is along the x axis and input is along the y axis. Actually, it is the first diagram is actually I spent time, because that would make much better sense. So, all the detailed discussions which I mentioned, that how the DMU which is inefficient can go vertically up, go horizontally out to the left, or go radially, would all be repeated in this diagram also. Now, consider the increasing return to scale. Now, in the increasing return to scale, again I am considering the idea of input along the x axis, output along the y axis. Ideas are same. The curve, as it is increasing return to scale, I will highlight it once first and then do the detailed discussion. So, this is the curve which is increasing return to scale, and all the DMUs are on this side of the curve and they want to reach the efficiency which is along the curve, which is marked in blue. Now, here is the analysis, same thing, but I will just repeat and highlight the important facts here. I consider the DMU which is inefficient, DMU 1 inefficient, and in order that this inefficient DMU which is 1, it can be efficient and can reach the efficient frontier. Again, there are innumerable ways, but I will consider only these three different ways of trying to move to the efficient frontier. One is moving vertically up, which is the pink line, going horizontally left with the blue line, and going radially, which is the green one. And if you notice, the pink one is mentioned as DMU 1 efficient IP, which is input oriented. One moving on to the left, which is the blue one, horizontal left, is as I mentioned, the color is blue, DMU1 efficient OP, which is output oriented, and if I consider the green one, again it is tangent 90 degrees onto the curve. This angle is 90 degrees. This angle is 90 degrees. So, if I consider this, the movements are, the green one would be trying to balance both of them. Now, let us see how the balance comes up for the pink, blue and the green. If I consider the pink one, it means that I am keeping the input fixed and I am increasing the output, exactly the same way we would have considered in the first diagram, which is decreasing return to scale, keeping input fixed, increasing the output. Now, when I consider the output being fixed, input being decreased, it is moving along the horizontal left, and when I consider the radial direction, it is basically a balance of trying to adjust the input and adjust the output. Now, the reason why I have drawn a DMU1 efficient input based, DMU1 efficient output based in different colors, pink and blue here in the increasing return to scale, and also in the similar way DMU1 efficient input oriented and DMU1 efficient output oriented, which are marked in pink and blue color respectively, will come to the model formulation when we pay specific attention to the decreasing return to scale model and the increasing return to scale model, where input oriented model or output oriented model, which is important and which is more plausible and one more practical, will be analyzed. With this, I will end this class and we will continue discussion on the DEA model later on. Thank you very much and have a nice day.